Alright, so now we're going to find some multiples and factors. Here is a multiple chart. So you might want to hit pause and take a look at this. So the multiples of, let's say, 5, just read them straight across from there. So 5, 10, 15, 20, 25, 30, and so on. Incidentally, if you count it from the top, look for the number 5, you can count straight down. 5, 10, 15, 20, 25. So this is just a chart. You've probably seen these for years. So if you need to come back to this, you're welcome to maybe have one on you, print one off. If you need me to print one for you, just let me know. I'll be happy to print you a multiplication chart. Okay, so in order to tell if a number is a multiple of 2, the last digit has to end in an even number. Even numbers are 0, 2, 4, 6, 8. So because part A ends in a 9, it is not a multiple of 2. Because, I don't know why there's 2 B's there, but anyways, because that ends in a 4, then yes, it is a multiple of 2. This ends in an 8, so I would say yes on this one as well. And this one ends in a 7, so I would say no, or it is not a multiple. In order for something to be a multiple of 5, the very last digit has to end in a 0 or a 5. So on part A, it ends in a 9, so I would say no on this one. On part B, it ends in a 0, so I would say yes. Okay, if something is a multiple of 10, that means it ends in a 0. So this ends in a 5, so I would say no on this one, but this one ends in a 0, so I would say yes. In order for something to be a multiple of 3, you add up the digits and see if that number is a multiple of 3. So the easiest way to do this, 6 plus 4 plus 5. 6 plus 4 is 10, 10 plus 5 is 15. Because 15 is a multiple of 3, I would say yes on this one. So on this one, again, add up the digits. 1 plus 0 plus 5 plus 1 plus 9. 1 plus 0 is 1. 1 plus 5 is 6. 6 plus 1 is 7. 7 plus 9 is 16. That is not a multiple of 3, so I would say no on this one. So if a number m is a multiple of n, then we say that m is divisible by n. I'll show you what that means here in just a second. So here's a divisibility test. Again, this is what I told you guys earlier. Last digit ends in a 0, 2, 4, 6, or 8. The sum of the digits is divisible by 3. Last digit is 5 or 0. Last digit is 0. Okay, so I'm just going to write down what it is divisible by, if it's a 2, 3, 5, or a 10. So I know that this is divisible by 2 because it ends in a 0, so I would say 2. I don't know about 3. Let me add these up. 1 plus 2 is 3. 3 plus 9 is 12. 12 plus 0 is 12. 12 is a multiple of 3, so I would say yes on 3. It ends in 0, so I would say yes for 5. It ends in 0, so I would say yes for 10. So it is divisible by all of those. Alright, so let's take a look at 5,625. It is not divisible by 2 because it ends in a 5. Let me add these up. 5 plus 6 is 11. 11 plus 2 is 13. 13 plus 5 is 18. So I would say yes on 3. It ends in a 5, so I would say yes on 5. It does not end in a 0, so I would say no on 10. So it's just 3 and 5 here. If A times B equals M, then A and B are factors of M. So that means a factor is something that can go into the number evenly. Okay, so if I want to list all the factors of 72, here's the easiest way that I have found. So I know that 1 will go in, and so then all the way down here at the end, and I could be leaving too much space, or not enough, I write 72. And I'll show you why here in just a second. Okay, so the next number that I know will go into 72 is 2. And 2 times what is 72? Well, it's 36. What is the next number? I know 3 will go in because 7 plus 2 is 9. And so 3 will go in. And 3 times what is 72? Let me make sure I'm doing this right. I don't want to tell you that. 24. Will 4 go in? I think so. Let me try. Yep, 18. 4 and 18. 5 will not go in. 6 will go in. 7 will not. 8 times 9. Check that out. Just enough room. So these are all the factors of 72. The reason why I did it this way is because I knew that once I had this, and then this, and then once I got down to right here, I would start repeating myself. So then I knew I had all the factors. Okay, a prime number is a counting number that whose factors are only 1 and itself. A composite number is a counting number that is not prime. So 5 is prime. Its only factors are 1 and 5. But 10 is not prime. It's composite because its factors are 1, 2, 5, and 10. Okay, so here's how you test to see if a number is prime. So you test each of the primes in order to see if it is a factor of the number. Start with 2, stop when the quotient is smaller than the divisor. The other way, and let me just tell you this is a lot quicker, is you can Google list of prime numbers. I know that's kind of cheating, but let's use what is necessary for today's world, and having to figure out if a number is prime this way that's on this page is tedious. Okay, for this page I'm going to do part B first because it's actually easier than part A. So part B, what you want to do according to that last page is you want to list or see if the prime numbers, any of the prime numbers prior to 77 go into 77. So let me just show you just a short list. This isn't a fully comprehensive list by any stretch, okay? So here's just a short list of the primes up to 77. 2, 3, 5, 7, 11. Now I'm going to stop there. The reason why I'm going to stop there is because I know that 7 times 11 is 77. Because these two prime numbers multiply to be the number that we're looking for, we would say that this number is composite. Okay? Alright, so now check this out. 83. Here's what I'm going to do. I'm going to list all of the prime numbers. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, and 83. Those are all the prime numbers up to 83. Absolutely none of those goes into 83. And because none of them goes into them, with the exception of the number itself, we would call this a prime number.